Computer Science 460, Agile Methods. This section of the book used to be Rapid Prototyping in Agile Methods. In the 7th and 8th edition, it was found in Chapter 17. So if you have one of those old editions, that's where you'll find it. In the 9th edition of the book, Somerville moved it to a more prominent position, specifically Chapter 4, and the 10th edition, which is the current, devotes the entirety of Chapter 3 to the topic. If you're a fan of this approach, you'll want to read through the chapter in detail. So, dissatisfaction with the overheads involved in the design of large projects led to the creation of Agile Methods. These methods focus on the code rather than design. They're based on an iterative approach to software development and are intended to deliver working software quickly and evolve this quickly to meet changing requirements. They're probably best suited to small, medium-sized business systems or personal computer products. And rapid development and delivery is now often the most important requirement for software systems. In particular, businesses operate in a fast-changing environment, and it's practically impossible to produce a set of stable software requirements. As a result, software has to evolve quickly to reflect these changing business needs. Plan-driven development is essential for some types of systems, but does not meet those business needs that are fast evolving. Agile development methods emerged in the late 1990s, and their aim was to radically reduce the delivery time for working software systems. Agile methods can provide useful software quickly when you have a constantly changing business environment or difficult to impossible to pin down stable software requirements. So there are many methods, but they have some common characteristics. Some of the methods that Somerville lists are DSDM, which is Dynamic System Development Method, originated in 1994. Scrum, this term was actually introduced in 1986 in the context of product development, but was introduced to software in the 1990s, and extreme programming. Some of the common characteristics: the process of specification, design, and implementation end up happening concurrently. The system's developed in a series of increments with stakeholders involved in version, specification, and evaluation. There's extensive tool support, for example, automated testing tools, rapid prototyping for user interfaces, and minimal documentation with a focus on working code. We can contrast Agile development with plan-driven development. Plan-driven approach to software engineering is based around separate development stages with outputs to be produced at each of these stages in advance. Plan-driven approaches are not necessarily waterfall model, though. For example, plan-driven incremental development is possible where iteration occurs within activities. In Agile development, specification, design, implementation, and testing are all interleaved, and the outputs from the development process are decided through a process of negotiation during the software development process. So overall, advantages are you have accelerated delivery for customer services and for programs, user engagement with the system. Disadvantage, lack of documentation. Contractual problems, what was agreed, because again, the lack of documentation, you don't have a set, concrete set of requirements that indicates what you're going to deliver. Validation problems and maintenance problems. Arthur Block says if you improve or tinker with something long enough, eventually it will break or malfunction. And a lot of what companies do is related to system maintenance. If you look at events such as Master of the Mainframe, you can see there's a real focus on having software engineers who are skilled with keeping legacy systems up and running. It's been a real challenge to produce maintainable systems when they are developed using Agile methods. So let's look at some of the principles of Agile approaches. So principles of Agile approaches are customer involvement, incremental delivery, people not processes, and I say Frederick Winslow Taylor rolls in his grave. He was the father of a theory known as scientific management, which was basically division of labor, hierarchy of command, etc. And you can look at Beck's article for details on that. Embracing change is part of the principles of Agile methods, and maintaining simplicity. So here is the Agile Manifesto. You all love to read Japanese, so here you go. It's available in a variety of languages at www.agilemanifesto.org. Here it is in English. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. And Mike's quote on this was, "It looks like they're replacing one set of BS with another set of BS." Leave that for you to debate with Mike. So one version of Agile software development is something known as extreme programming. And this originated with an article by Kent Beck called Embracing Change with Extreme Programming. And actually, we'll talk about the Chrysler project that kind of kicked it all off. It's one of the earlier and better known Agile methods. And the idea was to recognize good practices to extreme levels. It has a rather unfortunate name, since old curmudgeons are unlikely to want to adopt something that's labeled as extreme. The same thing with Scrum. I think Bain is right in that it brings cowboys and cowgirls into the fold, but it doesn't help much otherwise. Extreme programming has a technical focus, and it's not easy to integrate with management practice in most organizations. Consequently, while Agile development uses practices from extreme programming, the method as originally defined is not widely used. So, what are the old ways versus the new way? So the old ways are on the left, and the extreme way is on the right-hand side. According to extremeprogramming.org, extreme programming is successful because it stresses customer satisfaction. Instead of delivering everything you could possibly want on some date far in the future, this process delivers software you need as you need it. Extreme programming empowers your developers to confidently respond to changing customer requirements, even late in the life cycle. Extreme programming emphasizes teamwork. Management, customers, and developers are all equal partners in a collaborative team. Extreme programming implements a simple yet effective environment, enabling teams to become highly productive. The team self-organizes around the problem to solve it as efficiently as possible. The project report for Chrysler goes to extremes can be found at xprogramming.com, and it's one of the publications. Let's spend some time looking at these major practices in extreme programming. So one is the planning game. That is, customers decide the scope and the timing of releases. Programmers implement only the functionality demanded by the stories that are going into that release. And this goes with small releases. The system is put into production quickly, and then you have new releases that occur at a rapid pace. Another major practice, simple design, and this is more easily said than done. No duplicate code, fewest number of classes and methods, and there's a mantra, say everything once and only once. And again, it's more easily said than done. In regard to testing, this goes back to the Agile characteristic of extensive tool support. All tests must be run for every build, and the build is only accepted if tests are run successfully. In fact, you should plan to constantly run regression tests whenever new code is introduced. Test automation means the tests are written as executable components before the task is implemented. These testing components should be standalone, should simulate the submission of input to be tested, and should check that the result meets the output of the specification. An automated test framework, for example JUnit, is a system that makes it easy to write executable tests and submit a set of tests for executions. As testing is automated, there is always a series of tests that can be quickly and easily executed. That's the regression testing. And whenever any functionality is added to the system, the test can be run again, and problems that the new code has introduced can be caught immediately. Problem with this is programmers prefer programming to testing, oddly enough, and sometimes they take shortcuts when writing tests. For example, they may write incomplete tests that don't check for all possible exceptions that may occur, and some tests can be very difficult to write incrementally. For example, in a complex user interface, it's often difficult to write unit tests for the code that implements the display logic and workflow between screens. It's difficult to judge the completeness of a set of tests. Although you may have a lot of system tests, your test set may not provide complete coverage. Next major practice, refactoring, and from dictionary.com, refactoring is improving a computer program by reorganizing its internal structure without altering its external behavior. Fowler and Updike say when software developers add new features to a program, the code degrades because the original program was not designed with the extra features in mind. This problem can be solved by either rewriting the existing code or working around the problems which arise when adding new features. Redesigning is extra work, but not doing so would create a program which is more complicated than it need to be. Refactoring is a collection of techniques which have been designed to provide an alternative to the two situations mentioned. The techniques enable programmers to restructure code so the design of the program is clear. It also allows programmers to extract reusable components, streamline a program, and make additions to the program easier to implement. Refactoring is usually done by renaming methods, moving fields from one class to another, and moving codes into a separate method. Although it is done in small and simple steps, refactoring a program will vastly improve its design and structure, making it easier to maintain and leading to more robust code. And if you're interested in refactoring, take a look at Refactoring, Reuse, and Reality by Bill Opdyke, and Refactoring, a First Example by Martin Fowler, who's again one of the extreme programming gurus. Pair programming is the next bullet point, and that involves programmers working in pairs, developing code together. It helps develop common ownership of the code and spreads knowledge across the team. It serves also as an informal review process, as each line of code is looked at by more than one person. It encourages refactoring, as the whole team can benefit from improving the system code. In pair programming, the programmers sit together at the same computer to develop the software. Pairs are created dynamically, so all team members work with each other during the development process, and the sharing of knowledge happens during pair programming is very important, as it reduces the overall risk to the project when team members leave. It's not necessarily inefficient, and there is actually some evidence that suggests that a pair working together is more efficient than two programmers working separately, and there's some good literature in Sig C that discusses that as a learning practice. Other major practices: continuous integration. New code is integrated into the system within a few hours. Collective ownership. Everybody owns it and don't break the build. On-site customer. Customers should be closely involved throughout the development process. Their role is to provide and prioritize new system requirements and to evaluate the iterations of the system. Despite the importance of the on-site customer requirement, very few XP project studies report that they're actually able to fully implement this practice. And that's from Grisham and Perry. Another one is 40-hour weeks. You can technically work more than 40 hours one week, but you can't do it 2 weeks in a row. And open workspace, basically an open collaborative environment like CH13, and just rules. The team can change the rules at any time. Final practice in XP are stories. User requirements are expressed as user stories or scenarios. These are written on cards, and the development team breaks them down into implementation tasks. These tasks are the basis of the schedule and cost estimates. Stories should be business-oriented, testable, and estimatable. The customer chooses the stories for inclusion, or they want to include in the next release based on their priorities and the schedule estimates. By the way, you can see an example of a user story in Figure 3.5 on page 65 of the 10th edition, which I'll cover after the comic plays out in your mind here. That example deals with prescribing medication to a patient. The story is then broken down to task cards. So here's the user story. This is, again, Figure 3.5 on page 65 of the 10th edition. It's on the left. And this example deals with prescribing medication to a patient. On the right-hand side, you can see the story is broken down into task cards in Figure 3.6, which involves separating the story into 3 parts: changing the dose of the prescribed drug, selecting a formulary. A formulary is an official list giving details of medications that can be prescribed, and then checking the dose. Now, not everyone is sold on XP. Let's see why people may not be completely sold on the idea. Stevens and Rosenberg are particularly critical in their article Extreme Programming Refactor from 2003, and called the practitioners extremos. So they had some quotes. XPers are not afraid of oral documentation. Schedule is the customer's problem. Dependencies between requirements are more a matter of fear than reality, and concentration is the enemy. The authors do acknowledge a lot of good parts of the practice, and then they look at how they can actually work. Somerville himself says, "I'm not convinced that XP on its own is a practical agile method for most companies, but its most significant contribution is probably the set of agile development practices it introduced to the community." It's also been proven to be more difficult to implement than actually anticipated. Companies tend to pick and choose the practices that fit their culture and then use them with management-focused agile methods such as Scrum. And no discussion of extreme programming would be complete without a discussion of the C3 project. This was the Chrysler Comprehensive Compensation Plan. It was the first extreme programming project. It was also known as C3, and it was performed. It was used to perform payroll at Chrysler. It started in 1993, and so in terms of what ended up happening was it had a number of dignitaries on it, Ken Beck, Ron Jeremys, and Martin Fowler to begin with, and it was implemented, but it had a lot of problems, and Chrysler canceled the project in 2000 and effectively banned XP. The participants went on to very lucrative book deals. So in terms of Chrysler banning XP, the source is from the Extreme Programming Wiki. The impression among the folks I spoke to was that in the view of Daimler Chrysler management, C3 was a disastrous project, and never the like shall be seen there again. Grisham and Perry offer some additional details. A prototypical XP project is the Daimler Chrysler C3 payroll system, which has been self-documented by the members of the C3 development team and declared at various times to be a success. According to a brief report which doubles as an executive summary marketing brochure, the C3 team declares that they, quote, delivered a high-quality application on time and within budget. XP critics Stevens and Rosenberg have pieced together a different picture of the C3 project from posts to the XP Wiki bulletin boards and newsgroups. Their story suggests that at best, the C3 project delivered only around 1/3 of the requirements before being terminated, and suggests that XP as a process developed a bad reputation with the customer. None of this can be confirmed one way or the other, but it does suggest a potential gap between perceptions and expectations of the customer and perceptions and expectations of the development team in Agile Methods. Certainly the C3 team, as XP evangelists, should be expected to present the project as an overall success in the face of the project's termination. But in software development practice, with constantly shifting requirements and very short iterations, it should be very easy for a team to lose track of the larger project and goals. Although XP attempts to increase customer development team communication both in quality and quantity, it is still possible for gaps in expectation satisfaction to appear. So this brings us to Scrum and Agile project management, and we should start with discussing plan-driven project management. We'll get to see a lot of this in the coming weeks. Basically here the project manager draws up a plan that includes a Gantt chart, a PERT chart, and a project charter, requirements, documents, specifications, etc. And the project manager manages the project and tracks progress. Typically he or she will know, how many hours remain, the amount of effort required. Agile project management is slightly different. And basically, Scrum is one such approach. It's a general agile method, but it has a focus on managing iterative development. There are 3 phases: outline, planning, sprint cycles, and the project closure phase. So again, Scrum focuses on managing iterative development rather than specific agile practices. There are 3 phases in Scrum. The initial phase is an outlining phase where you establish the general objectives of the project and design the software architecture. This is followed by a series of sprint cycles where each cycle develops an increment of the system, and then the project closure phase wraps up the project, completes required documentation such as system help frames and user manuals, and assesses the lessons learned from the project. In regard to the details of Scrum, I'm going to post a presentation called Getting Agile with Scrum from Mike Cohn of Mountain Goat Software. He has a great YouTube channel with quite a number of presentations on how Scrum works. I highly recommend this one, along with other ones that I subscribe to, such as Kung Fu Theater and Old Maru videos. In regard to Scrum, there's a lot of terminology that you need to be aware of. One is Scrum itself. You have some experience with this. Scrum is a daily meeting of the Scrum team that reviews progress and prioritizes work to be done that day. Ideally, this should be a short face-to-face meeting that includes the whole team. 2. Scrum Master. Scrum Master is responsible for ensuring that the Scrum process is followed and guides the team in effective use of Scrum. He or she is responsible for interfacing with the rest of the company and for ensuring that the Scrum team is not diverted by outside interference. The Scrum developers are adamant that the Scrum Master should not be thought of as a project manager, but a lot of people say, well, there's not a heck of a lot of difference. The development team is a self-organizing group of software developers, which should be no more than 7 people. They are responsible for developing the software and other essential project documents. Product owner is an individual whose job is to identify product features or requirements, prioritize these for development, and continuously review the backlog to ensure the project continues to meet the critical business needs. The product owner can be a customer, but might also be a project manager in the software company or other stakeholder representative. Potentially shippable product increment. Software increment that is delivered from a sprint. The idea is that there should be a potentially shippable, which means that it is in a finished state and no further work such as testing is needed to incorporate it into the final product. In fact, in practice, this is not always achievable, but it's what you're going for. Product backlog is a list of to-do items which the Scrum team must tackle. They may be feature definitions, software requirement, user stories, or descriptions of supplementary tasks that are needed, such as architecture definition or user documentation. Velocity is an estimate of how much product backlog effort the team can cover in a single sprint. Understanding a team's velocity helps them estimate what can be covered in a sprint and provides a basis for measuring improving performance. And of course, I'd be remiss if I didn't talk about a sprint, and that's a development iteration. These are usually 2 to 4 weeks long. Let's take a look at these sprint cycles. The sprint is 2 to 4 weeks and has 4 components. First is assess, look at the backlog, review, and prioritize. Second is select. The project team works with the customer to select features that they want to include in that particular sprint from the product backlog. Third, develop. The teams develop the software. There are short daily meetings known as daily scrums with the Scrum Master. And review. The work is reviewed and presented to stakeholders. Again, the Scrum Master, at least theoretically, is not a traditional project manager. The Scrum Master does facilitate the daily meetings, tracks the backlogs, records decision, measures progress, and communicates with the customers. More detailed view of the sprint cycle is found on page 72, and it's figure 3.9 in Somerville, and that's 10th edition. As a simplified model, the sprints are fixed length, normally 2 to 4 weeks. Starting point for planning is the product backlog, which is a list of work to be done on the project. Selection phase involves all the project team who work with the customer to select the features and functionality from the product backlog to be developed during the sprint. Once these are agreed upon, the team organizes themselves to develop the software. During this stage, the team is isolated from the customer and the organization, with all communications channeled through the so-called Scrum Master. The role of the Scrum Master is to protect the development team from external distractions. At the end of the sprint, the work done is reviewed and presented to stakeholders. The next sprint cycle then begins. So one of the big critiques with Agile is how well does it scale, and I did post a video from Dave Thomas that talks about some of the problems with scaling Agile. And it's one of the big critiques. Agile is mostly suited to small to medium-sized projects. Large-scale systems are different than these. You have to have many different systems, both upstream and downstream, working together. Significant political issues. People have ownership of programs and systems. I remember one of the first days when I was providing training, and we had a new system that was replacing the old system, and I walked into the classroom as the instructor, and a woman screamed at me, "I can't believe you're the person who killed Cosmic." And so there's a lot of attachment to various systems, and don't ever underestimate that. There's a lot of configuration work for these large systems. How do you get one to communicate with the other? External rules and regulations, diverse sets of stakeholders. One of the ones I worked on with Ford Motor Company went everywhere from the people picking parts out of the warehouse to the upper management who were deciding what vehicles to build that year. And for a large system, most work involves system maintenance and not development. It's difficult to completely adopt Agile methods, but some adoption is necessary in order to be competitive. Somerville gives 6 reasons why large systems are hard. They include these 5 plus long procurement and development time. He also introduces the term brownfield system, which is a system that includes and interacts with a number of existing systems. So when I think of brownfield systems, I usually think of systems that are already in existence that need to be maintained, but Somerville has a slightly different definition. There have been some efforts to scale, and Dedden Leffenwell has quite a bit of background in the industry and has books from 2007 and 2011. So reading what he has to say is important, even if you're not a complete believer in Agile methods. Leffenwell text draws on ideas from classical management practices, Agile methods, and lean product development and combines these approaches. It also has some case studies. Of course, this is a 560-page book with 4 appendices, numerous references, and it's designed for people who don't want to read or be disciplined in the first place. IBM's Agility at Scale model, pictured on the left-hand side of the slide, is another attempt at this. They've also developed a framework called Agile Scaling Model, or ASM. ASM treats scaling as a stage process where development teams move from core Agile practices to what's called a disciplined Agile delivery, where teams take requirements and architectural design into account. The final stage involves incorporating and distributing development, complex legacy environments, and regulatory compliances. And there are other approaches out there, but they all recognize the following limitations. Completely incremental approach to requirements engineering is impossible. No single product owner for large systems. Not possible to focus only on the code. You need an architecture and documentation for the critical aspects of the system, and need to design cross-team communication mechanisms. Continuous integration is also not always possible. Well, looks like we just reinvented the wheel. So some items to consider, and these are discussion questions. Somerville's first one is explain why rapid delivery and deployment of new systems is often more important to businesses than detailed functionality. Or is this the case? You've probably heard the saying first with the worst, but is that really true? And there's actually some real debate as to whether first mover is a tremendous advantage. It's an active area in business research and in particular management information systems. An example of a second mover that has done very well for itself is Amazon.com, and they eventually took over the marketplace. Another example of moving too quickly into the marketplace can be found in the Xbox 360, which experienced a number of hardware problems due to the rush to get it out of the door. Question 3.3, extreme programming expresses user requirements as stories with each story written on a card. What are the advantages and disadvantages? The advantage to me seems to be that this is a natural way for people to communicate by telling stories, and it gets the project team started quickly. The disadvantage that I can think of to this approach is that it doesn't produce a heck of a lot of documentation that's usable for user documentation or system maintenance purposes. And suggest 4 reasons why the productivity rate of programmers working as a pair might be more than half of that of 2 programmers working independently. Price et al. Have an article entitled, Are 2 Heads Better Than 1 for Software Development? And the productivity paradox of pair programming, and that's in the MIS Quarterly from 2009. Extreme programming is currently gaining popularity as an So pair programming involves programmers working collaboratively to develop software, and they looked at the efficacy by comparing the performance, effectiveness, and effective responses of collaborating pairs with those of individual nominal pairs. Basically, they found that the pair programmers worked better than the individual programmer working separately.